Okay. Anyway, I call this Introduction to Glaze Chemistry, and what we're going to do is there are different sort of steps in the life of a glaze in terms of when we make a glaze. So you have the fired glaze that we end up with. That's the actual glass, and we'll talk about those in a minute. And then you have the unfired glaze, which is still the mix of the raw materials, the ingredients that are going into the glaze. And if you go back before that, you have the glaze recipe that you start from, which is this list of ingredients, the amounts and the list of the medians. And actually, before that, you have the chemical components of the ingredients. And we'll talk about that a little bit, because we use these ingredients because they're available and they're cheap, but they're not ultimately what we're talking about when we're talking about glaze chemistry. We're really talking about the chemicals, the oxide materials that are in these, which is really what determines the chemistry. But we're not going to focus on this a whole lot. I thought the most practical thing for this discussion today would be to talk about the recipes, because that's what most people are dealing with. If you see a recipe in a book, or you see a glaze and they say, well, here's the recipe for it, we're going to talk about, well, what are those raw materials? What is nepheline cyanide, and why is it in a glaze, and what does it do in a glaze? And sort of the general principles about how glazes function, why they do what they do. And then we'll talk about, and a big part of the handout you may have noticed is glaze recipes, because we'll look at some recipes and decide what can I learn just by looking at the recipe. That's the idea. You don't have to go into the chemistry incredibly deeply. Glazes are actually very complex. There's a lot to it, but we don't have to go into that to that depth. So I want to keep it at sort of the level of recipes where most people are working, where you're assembling the raw materials and you're making up a glaze. There are also certain things we'll talk about later where you can actually, in some cases, you can diagnose a problem just by looking at the recipe. With a little bit of experience and a little bit of familiarity with the materials, you can look at the recipe and say, you know, there's something wrong with that recipe. And as you may be aware already, there are probably more bad recipes out there than there are good ones. There are so many bad recipes out there that will never function the way they're claimed to function, through a combination of people. Somebody didn't know what they're doing, or they copy the recipe over and they copy it wrong, or they get the name of the material wrong, and there's just so many of them out there. It doesn't matter. And the online situation has made it even worse than the in-print situation. I probably have 150 books at home on pottery, and they all have mistakes in them, every single one of them. And the online thing is just worse now than it was before. So part of this is to get you a little more familiar with what some of the materials are, so that if you just look at a recipe, you can go, you know, there's something funny about that recipe. It doesn't strike me as you know, there's something wrong about it. At least it's a place to start, or it's a place to start diagnosing problems. Okay, so first of all, what is a glaze? Well, a glaze is actually glass. And there's a difference between, I'm going to have to sneak around here for a minute. There's a difference between a glass and other forms of material. Now we're going to get into a little chemistry here. Basically, if you assume that everything is made up of atoms, well, in most materials that if you looked around the room here, the material is actually, all the atoms are arranged in a very orderly fashion, a very geometric fashion. I mean, here's an example, a very common one. This is table salt. This is what the atomic structure of table salt looks like. You know, table salt is sodium chloride. So if you imagine, like, the yellows are the sodium atoms and the green are the chlorine atoms, this is the way they're packed together in space. Very regular. They just repeat forever. I mean, this is a tiny little fraction of a salt crystal that you could hold in your hand. But the pattern continues exactly like that indefinitely. So they're in rows, they're in columns, they're very geometric. And this would be called a crystal, or a crystalline material. And just about everything in the room is crystalline. Actually, glasses, as things go, are very unusual. Not many materials form glasses. And what a glass is, where the atoms are randomly arranged. There's no particular pattern to the way atoms are arranged. And the reason why that matters is because it gives glasses a very different property. There are some materials that can exist in a crystalline form, and you can also make a glass out of them. And the properties are very different. The same material, the same compound, is very different when it's a glass or when it's a crystalline material. So our glazes are actually glasses. Now, yes, they have some crystals in them sometimes. They're never completely crystalline, but they're mostly glass. Okay? And actually, and our glazes are also, we're dealing, you've probably heard of silica before. Our glazes are mostly silica. The chemical formula is SiO2, silicon dioxide. And all of our glazes are basically what are called silicate glasses. That means that they're mostly made of this stuff with some other things with it. But they're mostly silica. And we'll talk about what the other things are and why they're there. But they're predominantly silica. And silica, you see this a lot. If you walk around your yard, this is the mineral quartz. That's the naturally occurring, or one of the naturally occurring forms of silica. This stuff is everywhere. I mean, probably half of what's out in the parking lot is this stuff. Really common mineral. And this is what the glasses, this is the raw material what the glasses are made of mostly. Okay, any questions on that? So we're going to think in terms, and we'll bring this up again later, the fact that the glasses are mostly silica with other stuff along with them to help modify the way it behaves, to modify its properties, okay? Okay, so how do glazes work? Well, basically, we take a combination of these different ingredients, and we heat them until they all melt together, and then as it cools down, it freezes. And instead of crystallizing, like when ice freezes, it's actually crystallizing, okay? But when the glass cools down, when this melt cools down, it freezes into a glass. So we start off with materials, this mixture of powders or this mixture of ingredients that are actually crystalline materials, different minerals and chemicals. We heat it up and it all melts together and becomes completely homogeneous, and then it freezes and we have this glass. And that's our glaze. Okay? So we start off with, in terms of what we do, we have a glaze recipe, which is a list of ingredients. So look at the first page in your handout, the one that says examples of cone 10 glazes. And this is first of all, have all of you, or have many of you actually just even looked at glaze recipes without even doing a whole lot with them, but just even seeing what a typical recipe looks like? Has everybody at least done that? Okay, so this is not totally strange. So here's an example for a cone 10 celadon, and this is a typical recipe, 5 ingredients, and they're listed in terms of that W/O is the abbreviation for weight percent. That's percent by weight that I have over the right-hand column. And so they total 100%. And while we have this page, I want to talk about the correct format for a glaze recipe. This first one, the celadon recipe, which is a common way you see it, is not the correct way to show a glaze. And the reason why is when you talk about glazes, there's what we call the base glaze, which is most of what the glass or the glaze is. And then there are other things you add to the glaze to modify it. Maybe you change the color. Maybe you make it satiny. Maybe you make it opaque. All these other properties we like about glazes. They're not considered part of the base glaze. They don't fundamentally change the way it behaves, the way it melts, and the temperature. They're like additive, like modifiers, like putting food coloring in when you cook. You know, if you make a cookie and you put in green food coloring, it doesn't change the temperature that you have to bake the cookie at. So that's sort of the analogy, is that these other additives really don't significantly change the property of the glaze. That's the base glaze. So in this case, if you look at that first recipe, the red iron oxide, that's only in there as a colorant. So that's not part of the base glaze, and it actually shouldn't be included in the way this is written. The correct way is on the bottom. This is another recipe, green crackle. Now, the column on the left is the same format as above. The column on the right is where they've had everything add up to 100%. That's incorrect. It should be written the way it is on the left, where you have potash, feldspar, whiting, EPK, celebarin, carbonate equal 100%, and then the additive, the colorant, is shown as an addition. Okay, that's the correct format for a glaze. So that in the first example above, that iron oxide should have been taken out of there. It shouldn't have been included in the 100%. So you have the ingredients add up to 100%, and then you add the other things to it, okay? And the reason for that is, when you want to compare glaze recipes, it's very easy to compare them if you're comparing the base recipe, because that's what's really, and we'll talk more about this, but that's what's controlling the melting temperature and the basic properties of the glaze. Color is kind of just an additive effect, okay? So you really want to have the base glaze recipe by itself, and then the other things separately that you add to it, okay? This is why, for instance, a lot of commercial potters They don't have, people that are production potters, they don't have 10 glazes in their studio. Maybe they have 3. And they pick base glaze recipes that they can put other things into those recipes and modify them. So maybe they have one clear base glaze, and then they can put different colors in it to produce a whole spectrum of colors. Or they have one satin glaze that they can put a whole range of colors of things into, or one opaque glaze. So maybe typically 2 or maybe 3 glazes, that's it. And then they can add things to the base glaze to give the variety that they want. Okay? Excuse me. So we're going to be we'll talk about both. We'll talk about the base glaze, because that's really what controls the properties of the glaze, and then we'll talk about the modifiers also. The other thing I want to talk about right at this point is the next page in your handout. I believe it says converting parts to weight percent. We're starting off with a little technical stuff, but I want to talk about this up front. While we're talking about glaze format, as I say, the recipes properly should be written in terms of percent by weight. That's the way they should be. And then but occasionally you'll see them by what I'm calling parts, like this recipe here: custard whitening, EPK, and flint, and red iron oxide. And this is the way it might appear in a book, with the red iron, and the total is 300. So you say, well, that's not percent. So, and the things about percent, if you put it in percent, you can easily apply it to any size batch. You can compare one recipe side by side, because they're all in comparable terms. So if you see a recipe that is in parts, this is the way you convert it to percent. First of all, you pull out the additives. So I've sort of separated with a little extra space there the red iron oxide, because that's not part of the base glaze. That's a colorant. So I'm left with the 4 ingredients: custard whitening, EPK, and flint. And now I add those up. Well, together, the parts just add up to 297. Okay? And then I divide everything by 297, and now I get weight percent. So I divide 81 by 297, and I actually get 0.273, and you just move the decimal place over. Okay? And I divide 58.5 by 297, and I get 0.197, which is the same as 19.7%. And then I do the same thing even with the iron. I divide the 3 by 297, and that's equal 1%. So I'm adding 1% to the original total, okay? And so that's the way I can convert it. I just divide it by the total. But I have to separate it in terms of pulling out what's an additive. Does everybody follow that? Okay. And you'll see, more often than not, you'll see glazes not listed in percent, or you'll see them with the additives included. And I taught at Hood College in Frederick for 13 years, and it was embarrassing because even the handbooks we had in the college that were our own recipes were written incorrectly, so, and we never got around to correcting. For a base glaze recipe, you don't even need decimal points. Okay? You don't even really need that. Now, for some things, in terms of composition, like color is extremely sensitive to small amounts. So for color, yeah, you don't want to just say 1% of something or 2%. If you can, you might want to say 1 point something at least. I would say you never have to go to 2 decimal places. You just don't. Okay? And I've seen glaze recipes written out like 27.469%. That's baloney. Somebody went crazy with a calculator, but you don't need it, okay? So for the base glaze, this is the nice thing about glaze recipes, and we'll talk more about this, but when you combine these ingredients together, there's enough of a latitude. They don't have to be exactly dead on to hit that composition or something close. If you think about how the composition changes and the properties change, it doesn't jump dramatically. It kind of slides gradually. So if I change the composition a little bit and the composition moves over a little bit, the properties move over a little bit, not drastically. So you can have the base glaze doesn't have to be right on the money. As long as it's close, you'll get about the same glaze. Now, for colorants and some of these additives, yeah, you have to be more specific. But yeah, in this case, you don't need the decimal points at all. This is just the way somebody went crazy with a calculator.